One of the things that was asked about on Thursday's assignment was the difference between Arrhenius and Bronsted-Lowry acid bases. So it's sometimes just the way that it's asked in a question. Arrhenius acids might be like, which one of these four is an Arrhenius acid? So what I want to tell you is anytime you're asked about Arrhenius, whether it's an acid or a base, you need to come to table K and L. Table K is the Arrhenius acid table, and table L is the Arrhenius base table. So if I say which one of these four is an Arrhenius acid, and one of those is on table K, then I have the answer. If I ask which one of these four is an Arrhenius base, and one of these is on table L, then I have the answer. If not, I've got to look a little bit deeper. So Arrhenius acids, the key thing for them is when they break up, they will give off H plus in solution. We talked all about how things break up. If you were to look at this guy, this is a polyatomic. So this piece separates from this piece. You will not have an H by itself. If you look at this entire piece is a polyatomic. So this piece stays together and the H comes off. That's the Arrhenius acid, and it is on table K. When I put this together, this will separate into K and H, but K is the positive ion in the solution and H is negative. Arrhenius acids must be positive hydrogen. And lastly, this guy, when it breaks apart, he's going to break into K plus and OH minus. I do not have an H plus by itself in any case. Bronsted-Lowry, on the other hand, will always be asked in terms of an equation. In this reaction, who's the Bronsted-Lowry acid and who's the Bronsted-Lowry base? So what you want to do is connect the two pieces on the reactant side and the product side that differ. If you look, this is H2O, H3O. They're different by one H. Likewise, this HCl and the Cl are different by one H. A Bronsted-Lowry acid donates an H. So if you take a look, this water goes to H3O3. That's not donating an H. He's taking an H. In order for him to get from water, H2O, to H3O, he has to take an H. HCl going to Cl, he loses an H. HCl becomes Cl. That means he's the acid, HCl. The base must be H2O because it's the one that takes the H. If you look at this, NH3 goes to NH4. Think about that for a second. Did we lose or did we gain an H from going from here to here? We're gaining an H. That means that this guy, NH3, is the base. If you look, H2O becoming OH, he's losing an H. So that makes him an acid. So the key thing, again, just to sum this up, Arrhenius is going to just give you four formulas and ask who's an acid, who's a base. Bronsted-Lowry has to give it to you in the form of an equation. The only other thing I want to remind you is acids always have H, so they must give H. And that's in both the Arrhenius and the Bronsted-Lowry. Here's the H in the Arrhenius. You could see that we donate H to get acids in the Bronsted-Lowry.